Good afternoon, everyone, and welcome to the AMPC webinar today, which is around UV sterilisation and the opportunities that it presents for the red meat industry. We're lucky enough to have a couple of presenters from two companies, and Murray will introduce them shortly. So just a couple of ways that the webinar works in case you're new to the AMPC webinars. We really encourage questions, and we'll have question time during the webinar. If you'd like to ask a question, can you please type it in on, you'll have a questions bar in your tool taskbar. If you type that in, they'll come through to myself, and then when we have the opportunity, we'll ask Gordon and John, the presenters, to be able to answer those questions. We're also lucky enough this presentation has been designed by two of our co-innovation managers at AMPC, which is Murray Miller, who is our Victorian co-innovation manager, and Dave Dwyer, who is looking after the co-innovation and the plants in northern New South Wales and into Queensland. So I'll hand over to Murray for a bit of an introduction. Thank you.
Thanks, Amanda, and thank you all for joining us today. My name is Murray Miller. I've been around the meat industry for probably nearly 30 years in various capacities now. Probably many of you watching know me already, and probably most of you would like to forget, but anyway, that's for another day. During my time in the industry, I've become a great advocate for UV and discovered the virtues of just how effective that it can be on bacteria in our industry. UV has potential to be the silent killer of almost every bug in our industry, irradiating and disinfecting airborne bugs, production surfaces, knives, and even the water that we use on the floors. Today we have two very capable presenters who will expand on just how UV can be effective in those areas. So with no further ado, I'd like to introduce Gordon Jansen from Australian UV in Brisbane and John Brennan from Australian Ultraviolet Services in Melbourne. Now, although those two company names are similar, they are actually, in fact, different companies. So we have Gordon, the first cab off the rank today. So I'll hand over to you, Gordon.
Thank you, Murray. Hi, everybody. I think you can possibly all hear me. I'll just go to my show screen. Just a little bit about myself first, I suppose, would be the fact that I started a company about 6 years ago, actually as a result of I was doing duct cleaning and things, and then wanted to, sorry, trying to figure this out. So sort this out. Then wanted to find another way of complementing the things that I was doing for the industry that I was working in. Just get all this back to right, which was duct cleaning. So then discovered the merits of UVC and looked around the world and found a number of different companies which were manufacturing, and started the process of importing it into Australia and getting into predominantly HVAC systems initially in hospitals, and then realizing the benefit of UVC and how it can work many different industries. Started to look into food, and then again did the same sort of process and searched the globe looking for companies which had been in that space specifically, and approached them to become a reseller of their products or agent for their products in Australia. And from there have taken on all manner of different companies, so some American, some Swiss, some actually Australian, which I developed myself. So yeah, many different things. So the company sort of diversified over the last 8 years, 7.5 years. So what I wanted to talk about today was some of the products which are designed specifically for the food industry and predominantly meat industry. And this company is, well, the product is called Sterilisation. They, not the American Sterilisation, which people may have heard of, but Sterilisation, Switzerland, been around since, I think it's 70-something years they've been going for. and kind of like pioneers in their field, basically. One of their core differences is that they use different technologies to get high outputs of UVC in different atmospheric conditions. So through using, where is my thing gone? Through using different gases, they can get very high outputs. So using krypton and argon and xenon, the gases will behave differently inside the lamp to reach 0.67 pascals of pressure to get the optimum output of UVC. So they can go down to -20 degrees or even up to 65 degrees, depending on the lamp that we choose for the different environment. So that opens up a lot of opportunity with sorry, I just turned my phone off, with the environments that we can put the UVC in. So that all being said, what we will move into now is I'll start to take you through the product. This is basically just an overview of a factory setting of where UVC can be utilized. We've got it in the lab over here. We've got it in our cooling towers, in the trucks. People, put UVC into their trucks to line them, to disinfect like laundry cages and all sorts of manner of things. We have inline disinfection down here on our conveyor systems, UVC on our air coolers or evaporative coolers, air UVC on the air intakes for the fresh air intakes, and then in-room disinfection systems, which these UVR systems can disinfect a mold spore in one pass, which is extremely hard to do, and it's verified to do it. And then also in our cooling towers and water reservoirs. So versatile in so many aspects of business, and we'll try and sort of cover some of that off as we go through. So essentially, long story short, UVC breaks the DNA chain of a microorganism, so it becomes dormant, basically. It becomes a dead body. You still need to do your cleaning regimes because it doesn't, remove the dead body. So it's not like it would. People say that it keeps it clean. It keeps it disinfected. So you would still need to do cleaning, but you may be able to push it out for another 2 hours of operational running time and reap that reward through having that done. So that's essentially what it does. Long story short, they found there's all different wavelengths. There's 222 nanometer, which they are currently doing studies with, which are more or less, harmful to humans. So they're starting to wheel those out into movie theaters and things like that as of today, actually. So there's a new release on it. So a broad spectrum, but 254 is the chosen one for industry and everything else, because it's a very, very potent dose of UV wavelength C. This is just a brief example of like a petri dish which has been irradiated with UVC. Obviously on the left we have no UVC, and we have one that was irradiated with UVC, and that's basically sums up what it's going to be like on your surfaces and cooling coils, everything else. If it has a good dose of UVC, it will greatly inhibit the growth of microorganisms in your air or on surfaces or anything else. Where it can be used, so it can be used for air disinfection via your like internal ducting of a supply air, ducted supply air, or on the back of your evaporative coolers. In-room disinfection via the UVR and other products, which we'll go through. Surface disinfection by means of pass-through conveyors, UV wands. You can have UV wands, and conveyors of like chain for like a chain conveyors for proofing and cooling towers, cooling spiral coolers, and then obviously evaporative coolers and coils and things. So really, really, really wide and versatile. Within the meat industry, these are the three main products that are used internationally. We have here the UVR, which is an in-room disinfection system, does up to 700 cubic meters of air an hour, and can disinfect a mold spore in one pass. I think that's at 500 cubic meters of air an hour as opposed to 700, but can do it in one pass. And there's a full thesis written on these products to actually validate, that it can do the job. The second one is the ET series, or the E series. These are a modular system and can be literally made to fit anywhere, anything, anyhow. So you can do everything is based on these components, basically, from the E series, which I can go into more detail later on. And then the third one, which is the most popular in the food industry, is obviously conveyor belt disinfection, the T2018, because they conceptually finalized in 2018, hence the name. And so that one is obviously sticks either just below or like 2 millimeters below or just above the conveyor belt to disinfect on, whilst the process is is happening, so that you can extend that like sort of that process time without having to stop to clean if you've got a big run at the end of the day, sort of thing. Where they can be used, cold storage, basically with the UVRs, a lot of them where we've put them in overseas actually as well, just at Vanuatu recently, where they get dead legs, which are very common with the meat industry as well. And because by the very nature of all of our, facilities, you build and you build and you grow and you grow and you grow, and inherently from that you can get dead legs of air. So I like to use these things to help to push highly sanitized air around the environment and into those dead legs, so you stop that stagnant air from being heavily contaminated and causing problems. Because one of the main things with all food industry, no matter whether it's meat or anything, is the air. If you can sort your air out, you're going to be a long way to sorting out a lot of your problems. So that's where these sorts of products come in and are fantastic. Again, they can be used at -20 up to +35 degrees, and basically, 700 cubic meters an hour. Yeah. And then, so for those particular products, also just so you're aware, what we do is you take the room measurements and you take the height by the width and any other sort of dead legs, and they actually will size it accordingly. So they run it through the software, and we can tell exactly where to put the unit so that you're going to get the best overall disinfection, as illustrated in this. So you actually get a 3D, modular program that actually runs through it and shows you in all the different angles. There is a whole other presentation on that as well. So where you've got, new parts that you're either building, or the aircon may not be done quite yet, or any other problems, you can put these sorts of systems in to just make sure that you're going to be operating in a nicely disinfected space. Another thing actually with these is, and actually something I want to do was with someone, is put these above your process line. So if you can imagine, you've got your whole where your meat processing coming in at the start, and then it's all the way to the end. So you put these over the lines, so they effectively cause like a positive pressure of super sanitized air over that process line. So you won't be having the opportunity for any contaminant to be sort of, able to land on that meat in this case and cause, cross contamination through it being transferred onto the conveyor belt, etc. These are just other images of the UVRs and dry age, and just in situ. They're just some photos, because I find photos are really, they tell 1,000 bloody words. So very helpful to see those and to see how people use them. These ones are in Europe, these particular ones, but many of these other photos you're about to see are from Australia as well. They're sort of dotted throughout. So if you see your images, thanks for supplying them to me. So yeah, just some other general images. They do also have, just so you're aware, you can get like a cornered end. So if one was like where the walkway is there, because obviously UVC is harmful, you can get like an end and it just sort of twists around so that there's no risk to any occupant that may be walking past. Now we're on to the E series. So these are the super versatile products. You can put them on, you know, evaporative coolers and just absolutely anywhere to disinfect surfaces or air. Low maintenance, they're IP65 rated, and all stainless steel, obviously shadow protection. You can throw a water lance at these and there's no problems. They're all gasketed, sealed, lovely bits of machinery, of product. Can be easily retrofitted to any cooler, you know, and reduces, the lamps run for 12,000 hours, everyone pushes that out. So you normally get like a year and a half, maybe a little bit more before you need to change your lamps. That's what seems to be what everyone does. But then you will want to sort of change the lamps after that because they do lose their output eventually. And if you don't look after them and maintain them, then it's the biggest waste of money in the world. Some examples of the ET series in situ. So because these are in a shroud, you can actually put them in an occupied space. So as you'll see some other photos from around Australia as well, you know, you can actually work and walk around underneath these things and there's no risk to the occupants. So it's just, and these are just to illustrate a few of the different installation concepts. So you just sort of nut them together. There's a nut on the end and you sort of, that's how you do your installation. A few of you will recognize this photo. So this one's got 6 lamps on it for a duck sock air cooler and boning room. And they just literally, you don't turn them off. They're on all night, all day, every day. You just leave them on for forever and a day until they're time to change, and they'll just continually disinfect their air and obviously keep those cooling coils clean or disinfected. And yeah, there's just an example of the before and after, how it just cleans the systems out. One of the things that you find with the UV is because that has light photons, and the photons will actually break down particle. So if you've got like dust and contaminant, it won't clean them, but it will help to keep them cleaner, which I'll show you in another PDF a bit later on. It illustrates it perfectly. In fact, I'll do it in a second. So actually the photons break down the particle and stop them from becoming more contaminated than they need to. Initially, it works by the UVC stops biofilm from growing on the coil fins, and then because the biofilm is tacky, so then particulate in the air will stick to the biofilm. That will become nutrients for obviously the biofilm, and there all the bad stuff will start to grow on the cooling coil. So then when you irradiate it with UVC, that biofilm doesn't have a chance to grow, and then everything just washes away with the condensate. So if a dust particle, for example, or worse, sits on there, it doesn't become a source of nutrients. It just gets washed away with the condensate, and the coils stay clean. And in fact, I'll just jump over to that image right now. This is just jump over to this one. This is an example. This was done actually a very long time ago, like about 2015, I think it was. It's for a ready meal company. It's in Australia, and there was 3 fan coil units up on the main processing room where they were doing all the meats and everything else. So this again related to meat, and they were cleaning the units every 3 months. They were getting up there and doing a high pressure clean. We cleaned all of them back. Well, employed a duct cleaner to go and clean all of the coils with high pressure hose. Swabbed them all. They all came back as the minimums. And then we put the UVC on one of them, and then came back 5 months later, which is effectively what all of that says. And then we came back 5 months later, took photos, and we also swabbed them. These were the results from the microbial swabs. So as you can see there, the one with the UVC on it stayed nice and clean, and the other 2 had some issues. And then these are the photos. So that's the one with the UVC on it. And you can see there's a little bit starting to come back around there. So this is after 5 months. So they pushed this out by another 2 2 months in their normal cleans. And then this is the other 2. So they were all in the same room, on the same wall, big wall, but on the same wall. And that's the other 2 air handlers. And you can see, like, they are disgusting, basically. But you can actually see, because a few people have said, bullshit, that's, you know, it's not the same one, but it is. And you can actually just see here, like, you can see some of it starting to come back. So that time period, you know, it does show that it is coming back. So this is where I say you still need to do your cleans. It's not a cleaner, but it will disinfect and obviously, you know, help maintain your systems in a much more hygienic condition from point A to point B within the cleaning cycle. And actually, I'll just finish this one off. Sizing wise, how we do sizing. So we take the dimensions of the cooling coil. In this case, it was like 3 meters wide by 300 high, I think it was, some 250 high, a little bit more. And then we'll put them into the software and it'll tell us what kind of outputs we're getting to make sure that we're going to, you know, do the job effectively. And then as a added sort of estimation, and this is an estimation because these are variables, but it gives us an idea of the kind of disinfection we're going to get. We can do this on the recirculation. So we enter in like the average, which is the average dose in this case, which is 1588, and then we'll divide that by 3 for like a 0.3 of a second, and we get the 529. So that's about the estimated dose of UVC we're gonna you know, give to the air as it scoots past in one pass. And then we've got the air disinfection on pass 1, pass 2, pass 3, pass 4, pass 5. And so again, these aren't like documented, tested, but the physics of UV is a certain intensity of UVC will break down a microorganism and disinfect it after a certain amount of dosage. Like if we sit in it for long enough, it will kill us. So this is just an explanation to try and show to clients that, you know, not only will you be getting all the added benefits of the UVC from a hygiene and coil cleaning and everything else point of view, but you're also going to be, you know, disinfecting the air, you know, via that. And in fact, also actually, just in September 2020, they've just done some research on upper air UV disinfection, which is the same concept as what we'd be doing with the, you know, on the back of the cooling coils in your facility, in your processing plants, is like that's basically an upper air thing. So that's what this study was based on. But they found that with those units, they were getting a 72 to 80% effective reduction in transmission of airborne contaminants. So in this case, it was done for tuberculosis. But just to help again illustrate that, you know, there's all these other added benefits that you will be, you know, gaining from having the UVC on the back of your fan coil units, for example. Where am I? So that's sort of that. And there's a long list there of, you know, all the different microorganisms and how they break down. So it's just the susceptibility of different microorganisms to a given dose, in this case, 529 microwatts of UVC intensity. So, and that's that. So I just back out of that again. So that's the product. This is just explanation of mounting for the ETs on the back of the fan coils. You know, you can do something as simple as just a little bit of a bent plate and mount them like that, as you see in those other pictures. That's a long one, but the same concept. So very, very straightforward for the fabricators just to jump in and bend something up. So this is the ET product again, and just other, you know, uses for it within the industries. Disinfection of crates, you know, this isn't particularly for the meat, but you know, your white trays, and you know, so you can disinfect them either on circuit whilst they're going around for reuse after they've been washed or anything else. There's another barrier, or you can do, you know, individual systems like this. UVC can also be used. This is a pass-through tunnel. So this one, some of you out there may recognize this. This one is a grey to white disinfection cabinet, or pass through. So you got your film in there. You got it in. So put it in one end, put it into the reactor effectively for a given period of time. Open the door and take it out in the other room. So you can do that with anything you want, tools, whatever you're after. Another use for this particular product reapplied is for disinfection of your film. And this is a multivac. So you can put a tower onto your multivac machine and disinfect the film before it comes into contact with your product. That can be on the tray bottom or the top. And then it's just this one actually was more of just a show. That's not actually a real working product. This is just for a trade show that Sterile went to, just to illustrate how it can do the film as well prior to contact. Again, the service aspect is available to for the guys in Switzerland to mock it up for you and do all this. So they'll do all the sizing, they'll do your belt speeds. I should have put a photo up, that they'll actually do a full CAD drawing with disinfection rates, heat censoring, and everything. So we'll get what you're wanting to achieve. But they'll offer this also as part of that to get you in the right space, make sure that we're going to be getting the disinfection that we require. And also we can also offer which is what I've done mostly in Australia, is offer the step drawings. So people can obviously just go to their own fabricators with the step drawings and make up their own design, and I'll tell them how far away they need to be from the surface of the product, what the belt speeds are, and what our disinfection is going to be for whatever target organism they're after. They can be absolutely anything. So now we move on to the last of the most popular for meat industry, is obviously for food, is the conveyor belt disinfection. Why instant disinfection? Whilst production is running, microbial counts rise during the day, obviously. Minimise risk of product contamination from belt surface, and upgrade existing conveyor belts. So actually Forbo, not sure if you're out there, Forbo, but they just recently also released a new disinfection, UV stabilized belt as well. So some great stuff going on there with Forbo. And I've also got like a photographic sheet of different belts after exposure to UVC to show that they've never actually had a belt degrade prematurely from exposure to UVC, but we've got all the different belt types and images of them after they've been exposed to the equivalent of, I think it was 15 to 20 years of exposure. So that kind of information is available as well. Highly robust. I've got some photos which I can show you of the product. It's got a built-in reflector. It's got a built-in photo optic Teflon, which is actually built inside the actual lamp itself. Which, let's see if I've got a photo here, which I do. So here, this is the actual lamp. So this here is optical Teflon. So that actually reflects 97% UVC, and that's actually built into the lamp. So we're losing, well, only 3% output from any energy or any UVC intensity emitted below. It's been redirected and pushed forward back to the conveyor belt. That's how we're getting such good disinfection. They're using obviously all the IP69K rated connections, completely encapsulated. There's just some sizings for it. And again, so this is all completely encased. So this is all in the shatterproof sleeve, the entire lamp. So just to give you a little bit of information there, so that's actually a built-in reflector. There's two different sizes, about 890 and 600 from memory. So two different options there. Basic mounting for the standard system is as you see there. Very simple and very simple to take off and remove. Ideally, you want to put them on a little bit of an angle, because with belt slap, it can help reduce that and obviously not break lamps. There's installations here. Just some more images. There's the ballasts down there. There's a unit. There's no issues with, unless you go underneath and look up and deliberately go out of your way to inspect the lamps. There's no safety problems or anything like that. Just some more images. Some of you will recognize these photos. So just some example images so you can actually sort of start to imagine it yourself in your own facilities. Some more photos. So these are on top of the belt and below the belt, and these are all local photos. So this one, there was no space to go below, so they had to go above. So we re-engineered and put the option on the top. And then this again, like a photo, they weren't quite getting the disinfection that they wanted for this one particular problematic belt. So we put another one in there. So this one's actually got 3 on it. And there's just an under photo. And thank you again for those photos, guys. Then we move into just other applications of UVC within the industry. Of dry age. So these are like sealing units, basically. So you can walk in and walk around without being coming out with a suntan. These are obviously for dry age and salami. Just to give you some examples. This one here was for water. So this was, again, local. The water was used, 2-degree water was used to chill meat down after it had been cooked. And that water was becoming fouled on recirculation. So it would go back into the tank and then get repurposed. And it was becoming foul, so put the UVC in there. And then obviously that's the before, and then that's the afters. And there's just an example of the setup for the water tank. So you can use it to disinfect water tanks, headspace, because a lot of contamination you get is actually in the headspace. It's not just in the water. It's this area here because the air is contaminated. So you want to have these units up here above the water line to actually disinfect, all the surfaces, because condensate will carry the contaminant. So if you've got condensate in your reservoir and that drips down, so the story goes. It starts. Just an example of a wand, and then also over here is a UV knife disinfector with built-in water jets. So you're getting the best of both worlds in there. So trying to drop from that 72 degrees down to 50, 52 or whatever I think it is. That kind of system makes that possible. And I think that's about it. There's just some other products within the range, but again, all that, there's your DB for your things and the VUVRs and everything else. And now I think just from a safety point of view, just to touch on that, feel free to text me, anybody, if you want me to shut up. You can get units like this.
For you, Gordon, coming in. So once you finish the safety section, we might go to questions.
Okay, cool. So you can get systems like this, which are to the European standards. And so it'll actually, you put your sensor next to it and it'll tell you to make sure that, if you are going to stand in a specific area, that you don't stand there for too long, for example. So these kind of sensors are available, and some have got them in Australia as well. I'm currently using them just to make sure that that you're not going to be putting anyone in harm's way. Obviously, you use deflection shields and everything else to make sure that you're going to be safe. But this kind of product is available as well, so that you can, just rest assured your staff are going to be good. And also for these are called dosimeter stickers. So these sorts of things are available, and they show given irradiation. So once they change color, with a given amount of radiation. So 50 millijoules per cubic centimetre, it changes to this. That actually, so when you get that, that's Corona gone. You need 25 for Corona currently. And, you know, obviously up to, you know, all these things there. So that kind of product is available as well. So you could put them, I don't know, wherever the hell you wanted to really, and, you know, run some tests just to help, you know, help you feel comfortable that you're going to be getting the sanitation that you require. I think that's about, well, I could go on for hours, but I think that's probably about it. And yeah, if you have any questions, I'd love to hear them. Finished.
Sorry, Gordon. The first question for you that's come through is actually from Kurosh, who's actually in the UK and quite sleepy at the moment. He
Okay.
said, what is the rough cost of a typical setup over a meat conveyor?
Well, it changes. So I don't know what you're the UK agent would be. But
Probably if we're talking in Australian.
Sorry?
If we can just talk in like Australian, I guess, dollars, and then he'll sort of convert it anyway.
Yeah, so they're basically around 6K. 6,000.
Okay, the next one question has come from Monica. How does the lamp itself stay clean if there is so much, if there's particular dampened particles in the air from, is there lamp cleaning required?
So the lamp cleaning for the evaporative coolers, yeah, so what you can do with those is just with your standard, because you'd still do your cleans. So it's not that you don't ever do your cleans anymore. It just means that you know, when you do them, you haven't been contaminating the whole environment for, you know, that 5-month period or whatever it may be, for example. So for those ones, you just wipe it down just with a cloth when they're up there doing their other cleaning. And then that will just obviously take anything that which may be there, but also the light will sort of break down any particle, and it will, you know, keep it one, disinfected but clean. But normally, because the air's going the other way, on the back of it there's no real fouling, you could say. So we call that an upstream and a downstream fouling. So if it's a downstream installation, we'd account for fouling. So therefore, we would reduce the micro or the UVC intensity over time. So we'd start at, you know, this level, and then we'd end up sort of here, because we'd have to account for that fouling. But for the aircon units, they're all, majority of them are coming from the back and coming over it and pushing down and through and, you know, into the occupied space. So therefore, the front of the lamp doesn't get fouled at all. But you still would give them a wipe down and a clean with your standard cleaning regime, which you may, you know, push back if necessary. With regards to the conveyor system, I'll just see if I can show you a quick video. Oh well, actually, I can show you this one. So this is just showing the IP. I'll speed this up. So it's just getting the IP rating. So you can water blast the buggery out of them, and then actually on site, that's just an example of how the base system works. But here you go. So you can actually just water blast them.
Great, excellent. The next question comes from James, and he has asked, how does UVC differ from ozone or hydroxyl generators?
One's an aerosol and one's not. So whether you're ozone or photoplasma, hydrogen peroxide, obviously are producing an aerosol. They 100%, and I also sell those products as well. they have their place because they get into all the nooks and crannies that, like say, for example, UVC doesn't. But then at the same time, they're a balancing act for safety. So, for example, if you can put ozone into it, you need to just do a little bit of homework into the environment. What kind of contaminant you're trying to disinfect? Is it a contaminant which is a continual source of contaminant, or is it a contaminant that comes intermittently or sporadically throughout the day? So therefore, you need to treat it at that time. And that's what needs to be understood. But is ozone a fantastic disinfectant? Absolutely, it is. And it's used massively throughout the food industry. And fortunately, because of COVID, it's actually had a bit of a revival. I'm sure the ozone guys would say that's not true, but I would say from myself and the inquiries that come through to me, whereas before everyone was like, oh, ozone, don't want to know it. Now they're sort of more open to it. So yeah, great product, has its purpose. Doesn't break down like on the back of an air conditioning unit because it doesn't have the photons to actually do like physical change. So it behaves differently, and it's also because it's in air. It's like water. It takes the easiest route. So if you've got an air conditioning system this big and this fan's working here, but that one's not, it's all going to go through that one fan. The other side isn't going to get anything. It will, obviously, on the greater recirculation throughout the entire premises, but it'll take a little while, and you know, it won't be as potent as, for example, opposed to UVC on the back. But yeah, ozone and like I say, photoplasma and everything else is fantastic, and I use it all and advise it, dependent on whatever the client's issues are, or you know what the challenges that they're trying to overcome.
Great. Well, thanks, Gordon. There are a few more questions still coming through, but what we might do is hold them over to the end after John has done his part of the presentation, and then we might have a bit of a question panel so you don't get hit up with all the questions and John escapes from them. So if you don't mind sharing screen now over to John.
Yep. All right.
And everyone, we've now got John Brennan. There he is, who is now going to be able to do a second part of the presentation, who is from Australian Ultraviolet Services Proprietary Limited in Melbourne. Thanks, John.
Hi again. So we're located here in Melbourne, and we're been manufacturing, designing and servicing ultraviolet products in air and surface disinfection, odor control and phototherapy for almost 40 years. We were set up by John Sly back in 1982, and then Robert Sly is sitting over in the wings over here. He's our current managing director, and he's been around for over 30 years, part of the fabric of our company. We've worked all over the world, from South Korea, South Africa, Malaysia, New Zealand, but majority of our work here in Australia, from large projects of treating sewage and potable water systems right down to UV in household water treatment. We're members of the International UV Association, and majority of our equipment is manufactured here in Melbourne, in the factory behind me. We have dedicated lamp manufacturers, UV Air, and we build a lot of our own transformers as well. We're proud to be wholly Australian owned, and our basic philosophy is providing ecologically sustainable solutions for air and water disinfection, and to try and extend shelf life of food and prevent spoilage. In regards to air disinfection, we use computer generated algorithms to provide the correct dose of speciation to from everything from breathable quality air all the way through to lab controlled environments and operating rooms. We built overtrack units for belt irradiation, as we were just discussing, and a variety of different applications there. including ozone, but mainly non-ozone units. Carry a variety of water disinfection units from 450 litres an hour up to 150,000 litres, applied to both potable and secondary effluent treatment, and then serviced regularly by people like myself. We provide watermark units with our water sterilisations, and we have them sourced and built locally using 316 stainless. Pride ourselves on providing a long-lasting product and providing service. We've manufactured a lot of other custom projects and sterile holding cabinets for item disinfection and tools, everything from shovels to utensils in labs, things like that. And as you saw with Gordon's showing you plastic wrap treatment, same kind of thing for finished products, applying that to plastic wraps and foil wraps on the end of food processors, and also providing disinfection for overtrack units on belts, like with for fruit, fruit sorting, pastas, things like that. And then also use whole cool room UV units, our IM units. It's one of our bread and butter products, where bacteria naturally forms on meat. So we use our cool room irradiation, where it controls bacteria, mold spores, yeasts, and because it slows down the microbiological action, the food products retain their freshness, and you're able to increase the humidity in the room and the temperatures without causing spoilage, and therefore you get less weight loss in your meat and less spoilage, basically. Eliminates odors as well, creates through the ozone usage, breaks down the odors in the room, and then extends by stopping the sticky buildup that you get on your meats over time. One of our units is sufficient for 5 square meters of treating red meat, and on meat like pork and chicken, it's about half, so 1 per 2.5 square meters. And then Gordon had brought up some of the UV dots in terms of checking the radiation output in your UV dose. We use those as well, and then you can periodically put up stickers and see if you need a lamp change, but generally 9,000 to 12,000 hours on a lamp life, and changing them every 1 to 2 years depending on use. We also so then we've had tests done on these units, independent tests by CSR IRO. They've found that the storage life of meat is through their testing is approximately doubled, and using these IM units are used in conjunction with the existing cool room fans set up and allow the airflow to move past, create an airflow where it's killing the microbe as it goes past, and then the minor ozone production is helping to dampen odors and kill where the UVC doesn't directly penetrate, and designed to set up in with our ballast set up along to protect it from the draft of the fan, the actual UVC light itself. And I'll just go through and show you a few things here. So we have, these are just some of our sites in Australia. These are the basic wavelengths of the UV. So your UVA that we use in phototherapy, so the pictured black light, it's that sort of thing in bug zappers. And the UVB, you can see the big lamp pictured there. It's used in phototherapy for treatment of psoriasis, things like that. And then the UVC, which is what we'll be focusing on in the meat, which is our lamps are made to 254 nanometers wavelength of light, and we produce both ozone and non-ozone producing lamps. As an example of one of our water sterilizers, it's a PAL348, I think. So that's a amalgam system. And there's an example of sleeves, one dirty, one clean, and not much light goes through the dirty, so they require regular service depending on the quality of water, and are able to be provided in a variety of sizing from, mentioned before, from 450 litres an hour to 150,000 litres an hour. And these are some examples of our phototherapy units, a hand and foot unit in the middle there, and a whole body unit up on the right, and to help control psoriasis and used in dermatology offices. Here's an example of one of our over-track units on the left here. You can see the connections and fans on there, but basically protected from direct exposure to the light and built to suit the size, speed of the belts, and whether it's a overall UVC disinfection or whether they have a particular mold or bacteria that they're trying to treat, we do speciate. We isolate the sorry, phone's going off. Isolate what is needed to be killed through swab testing, and can provide, based on belt speeds, things like that, exactly what dose you need. It's a little UV unit on the left here is a deodorizer. That's a small ozone producing lamp in there that provides very trace amounts of ozone. Can be used in office areas, things like that, for odor control. Have bigger versions for things like bin rooms, things like that. And then this over on the right here is an example of a bath unit for water disinfection for wastewater. So the water comes in at the end here and spills over through the UV. This is an example of water treatment in a fish farm with use of ozone as well. And you see at the end here, so we pump the ozone into the water to treat it. And at the end here, the UVC itself helps to kill any excess ozone before it leaves into the fishery. One of our servicemen treating a sewage treatment plant, one of our big systems. So these are regularly maintained racks of lamps. They have to be cleaned every 3 months or so. And then if there's large amounts of rain, even more so. This is an example of, on the top left there, that's one of our units that we use in our meat rooms. So the bracket is been taken off it there, but it's and the ballast will be at one end. And these are mounted in the roof on a door switch, so when your butcher comes in, the lamp goes off, and when you close the door again, it comes back on. And the direct UVC provides disinfection for surfaces, and then with the ozone filling in the gaps. Another applications here on pump stations where we use ozone, and then one of our sterile holding cabinets, one of our smaller units, which is used for disinfecting utensils and labs and things like that. And yeah, that's basically it. Any questions you have?
Great, thanks, John. I'll probably I'll send a few questions your way, and between yourself and Gordon, you can probably both jump in and answer as appropriate. So the first questions come from Adam. Has there been any study on limiting the spread of airborne components of COVID-19?
Yes.
Gordon's onto it.
We've got the sneaky, we can't see you in the camera, so.
Oh, so let me turn it on. Yeah, okay, hold on. There we go. Yeah, so there's actually been quite a few. One of the other products that I actually import from the States, they're just in their stage 3 final stages of the COVID testing. So they've done preliminary ones, a preliminary one, which has been approved. So they've said like in 0 to 2 seconds of exposure to an air, that the SARS is, or COVID-2, not, anyway, is disinfected to 99.9, I think it is. And then we're waiting for, I've actually just requested the final reports to come through so I can get airflows, velocities, duct dimensions, all that kind of carry on, so we know exactly specifically what we need to do to achieve those disinfection rates. There's other, yeah, so there are a few coming through with actual COVID. So it's been, obviously, you can't just go down the shop and buy a load of COVID to go and do your testing with. So it costs a fair bit, and then you've got to go through all the safety and everything else to be able to do it. So yeah, Fresh Air UV have actually just done that, and they've got the results to show that it's there. And I will have those actually very, very, very soon, because they're just on the stage 3 final trials of it now.
Great, thanks for that. So the next question, John, it's probably for you. How effective is UV on the shadow side of the light?
So the direct UVC, it's only where the light reaches. So that's where, in the instance of a cool room, that's where the ozone comes into play and helps to disinfect in those areas that the UVC is not directly filtering to. I can also bring in the guru Robert Sly for a bit of Q&A as well. So.
Excellent. All right, we'll throw him in the deep end then. So the next question has come through. Does UVC heat the air or surface?
No.
Well, no, not really. UVC adds nothing and takes nothing away from the product. It's only when a product is up close to the lamp and the lamp is giving off some heat energy, that's the only time it'll heat up. It's not like at 1 metre or 2 metres away from the light source that the product's going to heat up. So it won't heat things at those sort of distances, but up close to the lamp, yes, it will start to increase the temperature. One of the other things John talked about before is the lamps that we produce are low pressure mercury vapor lamps. We also handle amalgam lamps. Low pressure mercury vapor lamps start to lose their punch at around about 40 odd degrees, whereas amalgam lamps will run through to 100 degrees C with no reduction in their output. So there are a number of different types of lamps available. Obviously, the amalgam lamps put out more heat than what the low pressure mercury vapor lamps do, but for all intents and purposes, at a distance from the lamp, it won't heat up product.
Great, thank you. And another question's come through. If someone only installed either a belt disinfection unit or a cut product unit, which would you recommend for shelf life? does zapping the product act as a catch-all?
It'll depend on the product too. So I would say no, not a catch-all, because that's where you see the wraps themselves, they might be contaminated, so you treat those, treat the belt, and then you'd have to monitor the whole process as well and make sure there's no weak points in which microbes would be able to get in.
Yeah, but I always say it is, and the biggest term that I find that the industry uses is it's another barrier. It's another thing for the for the contaminant to have to get through. It's called disinfectant. Like normally, well, I definitely don't class UVC as a sterilizer. Like I don't use it sterilisation. I say disinfection because of that point with the shadow spot. Even like when you're disinfecting fish and salmon and stuff, you've got to, because it's the porous nature of the skin and everything, to get those angles and stuff, to get really high disinfection is very particular and very takes a lot of work to get the right thing. So, and again, whilst you can say you're going to get a 99% disinfection of the contaminant on there, there's still always that nook or that cranny. So I don't know what you think, John. Like there's it's a risk reduction is what I always.
No, yeah.
I can.
Your difference between a 99% kill and 100% kill can be quite a bit as well. In terms of output.
And I guess following on from that, one of the questions has asked, is there any food standard requirements, and from a standards point of view, especially with overseas export markets, with their acceptance to UV?
Some time ago, and I'm talking probably 10 years ago, the Americans were a little bit worried about meat products that were irradiated by UV, but of recent times, the Americans have realised the benefits of ultraviolet disinfection on meat products, to the point where we supplied $50,000 worth of lamps back to America just recently for the treatment of face masks that were in great shortage in the United States. And I felt that was a feather in an Australian's cap, or Australian manufacturer's cap, to be able to be exporting back to America. So really, to answer the question, I'm not too sure how the Americans feel about their product being held under UV, but at one stage they weren't terribly happy about it. I think that mentality's changed though.
Yeah.
Great, thanks. I'm just going through some of these questions that are a little bit doubled up. So we might go to wastewater now. Do you provide services in wastewater treatment industry, to be more exact, removing microorganisms in treated water to meet potable water specification?
Yes, we do.
Great. I think you might get a few phone calls from a few meat processors, because I know that's one of the hot topics around the country that we often hear as co-innovation managers at AMPC. So the next question is, what kind of exposure time is required for the belt?
That'll all depend on belt speed, what microbes you're trying to kill. So that's where it comes down to what we run with our air disinfection. We put it into the algorithm, and then that different factors come into play, including air temperature. So everything's basically designed to overkill, but the time to kill basically depends on what you're trying to kill, because the toughest molds are going to take 10 times the amount of UV dose to kill as E. coli or some of the more common bacteria and viruses. So,
yeah.
Great, thanks. Now to a more technical question, in terms of what's the approximate kilowatt usage for operating a conveyor belt system?
can tell you exactly. I do, off the top of my head, I don't actually know. I could fluff around on the screen and tell you exactly, but I mean, I can find it out. I will have the information.
Look, if you don't mind me jumping in, based on what John said about how much energy you need to inactivate these bulbs on a conveyor line, typically you would use a couple of G48 lamps, which are lamps that are in the old scale 4 foot long. Each one of those lamps would draw about 54 watts of energy, so 108 watts of energy, and that's about as close as I can get to answering that question.
No problems. I might give the person that asked that question, if they want more details, I'll give them your both your details to be able to make contact. The next question is, are there any commercial products using LED technology as opposed to UVC lamps?
Yeah, we've seen some applications. Actually, I've got a little LED on a drink bottle here, but they are quite, testing we've done on them is they don't have quite the same intensity as a low pressure mercury vapor. So for larger applications, we haven't seen that there yet. But for something smaller, like even these, like food storage containers, has a little UVC LED in it, but the effectiveness isn't close to the other products available.
Yeah, you need a lot of them as well to get the same amount of wattage, and a decent one can cost up to like $30 odd for a good half decent lead, but you won't get the distance up close. You can get a good maybe one. Like, it's not quite there yet. It will be, but not quite yet.
And the time needed as well under those is quite a lot longer.
I actually have one for split systems, and I've got the micrology report as well, which works. It works great, but it has to be a higher wavelength so it doesn't break down plastics or hurt your eyes or anything like this. So, but what that means is because it's in a split system, you've got a fan barrel whirling around. It's got sort of all night and all day to do it, so it's got a longer dwell time. What we're working with in the food industry, because everything's cruising past at a hell of a speed, we need we need to neutralize that organism as fast as possible. So therefore the LED, unless you had an absolute ton of UV's LEDs across the length of the conveyor belt, for example, would cost like, just, and you'd have to be super close for a long period of time, space-wise, everything else, it's not quite there. But if you've got a long time, can you disinfect a space of belt? If you were to leave it there for a minute or whatever, and then yeah, fine. But you don't, you don't have a minute to deal with, when you need to do it fast. Does that make sense?
It does. So the final question as we wrap up, and there's probably a few questions that we'll talk offline and get some information back to people. So if we haven't answered your questions, we will come back to you. This question is probably related not only to conveyor belts, to any surfaces that are being treated. If it's not effective where the light doesn't hit, how effective is it with conveyor belts, and how do you suggest using it? So like if there's meat and fat on the actual conveyor belt, wouldn't that be the part being sterilised rather than the actual belt during production?
So we would go the top and bottom, and not a solid conveyor belt. It depends on the application, but like, if you're treating the top side of a lid, you might have an over the top conveyor system that's only needs one side, but otherwise you might have a conveyor moving along with interspersed lamps along the bottom and on the side walls as well, so it's irradiating from every direction.
Yeah, it's like I'm doing a fish or seafood place at the moment, and the air contaminant is coming through the bottom. So we're doing it in the top and the bottom. And again, it's like, yeah, you just need to listen to every individual client and what their problems are, and see what understanding they have of where it's coming from, what they can track on it, and then obviously provide solution which is going to do the job, which in some instances it's just top disinfection to stop cross-contamination. Other ones, because of the nature of the product, it may, you know, penetrate through the belt, which could be a different belt choice as well, to be honest. And then you know, irradiate the insides and the tops, like what John was saying. It just depends on what the individual circumstances to get around those shadow points, for example, or just to get the full coverage of where the contaminant may be coming from.
Great. Well, thank you very much for today, both to John, Robert and Gordon for doing all their presentations and giving us a really informative session. We've had really good feedback around both your presentations and also the Q&A. So I'm sure there's going to be more Q&A coming your way. Just in closing, yeah, thanks once again for your time and all the efforts that you've put in. If people do want further information, I suggest that you reach out to your co-innovation managers in each of the states. So over in Western Australia is Blair Bryce, down in Victoria is Murray Miller, New South Wales, either David Dwyer or myself, and in Queensland, your co-innovation manager would either be David Dwyer or Sean Starling. And we will be able to make sure that we can get the right connections for you. So please reach out. But if you want more technical information and applications, definitely talk to also Murray and David, because they've both used them in different facilities that they've been involved in over the years, in all different sort of products and that as well. So thanks again, everyone, for joining. It's been a fabulous session and we look forward to catching up. I think our next webinar is in 2 weeks' time. So enjoy your afternoon. Thanks very much.
Thank you.
Thank you.
Thank you.